Are you a student that confused and want to learn about matrix? Congratulations, you are on the right video. I forgot again, bro. Let's learn matrix now.
Yeah.
Learn matrix, a computer science topic, backbone all of the application,
Okay.
computer graphics, for data analysis, engineering. What we will learn is basic of matrix.
Yes.
Remember, it's just basic. Learning operation between two matrix, subtraction, also between two matrix,
Yeah.
addition. Let's learn it first. How about the type? They are square and rectangle. Then I read it. Also, rough vector. Don't forget column vector. And matrix in first. I think it's not easy. Cause you need a way to find the identity. Identity. Matrix one is secret to learn. I don't get it. Feel like I need to find the determinant. Run into the properties and I grade it.
Yeah.
I forgot again, bro. Hello everyone, my name is Chandra and today we're gonna learn about matrix in linear algebra. So why do we need to learn about matrix? Well, it's simply because in computer science, matrix are the backbone of countless applications from computer graphics and physics to data analysis and engineering. And today we will learn about it. And what we're gonna learn today is understand the fundamental structure and notation of matrix. So we're gonna learn about the basic of matrix, explore various matrix operation. Yeah, we're gonna learn about matrix operation also, like addition of between two matrix or subtraction between two matrix or multiplication between two matrix. And we also gonna learn about how to inverse a matrix. In linear algebra, a matrix is a rectangular array of numbers, symbols, or expressions arranged in a rows and column. It is denoted by a capital letter and typically represented within brackets or parentheses. So yeah, just the notation explanation. Matrix usually have rows and columns. For example, we have M by N matrix, which indicate M is the rows and N is the columns. You can replace it by number, for example, 2 by 3 matrix or 2 by 2 matrix or 3 by 3 matrix. Each of the value always have an elements which is it represent specific value or symbol within the matrix. As you can see, there is a visualization in this slide. There is 3 by 3 matrix and the element is A11 until A33. The A11 indicates it is placed on the first row and first column, where A33 is placed in the third rows and third column. You get it? Matrix can be of different size and dimensions. It's ranging from 1 by 1 to larger dimension. So the range of matrix is actually unlimited. You can either make 11 by 11 matrix, but it will be hard to calculate between two matrix if they have larger dimension. There are so many variants of matrix, like this one, square matrix. So it has an equal number of rows and column. As you can see at the visualization of the matrix, that is a 3 by 3 matrix. equal number of rows and columns. There are also a rectangular matrix, which has a different number of rows and columns. Look at that matrix. That is 2 by 3, I think. Okay, yeah, am I right? Yes, yes, that's 2 by 3 matrix. And also, row vector is a matrix with only one row, you know? So it is a 1 by 3 matrix. And also, column vector, which is a matrix with one column. Yes, that's one column of a matrix, which is
I think I'm wrong. I think
the row vector is 3 by 1 and column vector is 1 by 3. I apologize. Next, we have
identity matrix.
which is a square matrix with ones on its main diagonal and zeros elsewhere. So, as you can see, the ones make diagonal line in the middle, right? You can see. So this is the 3 by 3 identity matrix. Okay. And soon I will be show you the 2 by 2 diagonal matrix.
I mean identity matrix. 2 by 2 identity matrix.
Okay, enough explanation for basis matrix. And now let's jump into the matrix operation. First, matrix addition. If it is hard for you, it means you need to.
Get back into elementary school.
So, matrix addition involves adding corresponding elements of two matrices together. So, to be able to do matrix addition, the matrix must be have the same dimension. For example, 2 by 2 and 2 by 2, 3 by 3 and 3 by 3, or 4 by 4 and 4 by 4. So if the matrix have different dimension, it's not possible to do the matrix addition. So for the properties, we have commutative property. The order of addition does not affect the result, of course. And the grouping of matrix also doesn't not affect the result. Let's get into the formula. For example, we have two square matrix. Both of them are 2 by 2 matrix, like this. And the formula will be like this. You just need to do the addition operation with the elements that have same position. For example, this is at the first row and first column. This one also have at the first row and first column. That's why it'll be like this. This one as well. And this one as well, this one as well, this one as well, and this one as well until the end. This is the formula to find the matrix addition. Let's see the example. In this example, we have two matrices. Both of them are also 2 by 2 matrix. And to do the matrix addition between these two matrices, all we need to do is just do the operation of addition with the elements that have same position. In this case is 2, so we do 2 plus 5. And this one also 3 plus 1 and 1 plus 2, 3 plus 4. And it will be like this, right? And then just calculate the rest. 2 plus 5 is 7, 3 plus 1 is 4, 1 plus 2 is 3, 4 plus 3, 7. So the answer will be 7437. 7437, correct. Easy, right? Next, we got into a formula of 3 by 3 matrix. It is almost the same, but the difference is it just have different dimension. So you need to add more calculation to do in each element. And this one is 3 by 3 matrix. All you need to do is just do the addition between this element and this element. This one plus this one plus this one, and this one, this one, blah, 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 until this one plus this one. It will be like this. Okay, this is the formula to find matrix addition between 3 by 3 matrix. And also let's just see the example real quick. Yeah, this is two matrix of 3 by 3, and all we need to do is just do this 2 plus 5, 3 plus 1, 5 plus 4, and then 1 plus 2, 4 plus 3, 6 plus 7, 7 plus 6, 8 plus 9, 9 plus 8. Let's visualize it like this. And 2 plus 5 will be 7, 3 plus 1 will be 4, 5 plus 4 will be 9, 1 plus 2 will be 3, 4 plus 3 will be 7, 6 plus 7 will be 13, 7 plus 6 will be 13 as well, 8 plus 9 is 17, 9 plus 8 is 17. Oops. Yes. This is the answer, and to make it easier, yeah. This is the answer of this matrix addition. Is this right? Okay. And then now we move into matrix subtraction. This is very easy. Even my
1-year-old baby can do it with closing his eyes.
anyway, matrix subtraction involves subtracting corresponding elements of one from another. For matrix subtraction to be possible, the matrix must have the same dimensions. It is pretty much same with matrix addition. And properties for matrix subtraction. Subtraction can be expressed as addition with negative matrix. As you can see, like,
Yeah, yeah.
okay, so the formula will be like this. For example, we have again 2 by 2 matrix, matrix A and matrix B. To calculate it, it's pretty much same with the matrix addition. You just need to subtract this element and this element, 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 and then we got the visualization right here. This is the formula to find subtraction between 2 by 2 matrix. Let's jump into the example. We have this matrix with this matrix right here, matrix A and B. To calculate it, all you need to do is just subtract this element and this element. So 2 minus 5 and 3 minus 1, 1 minus 2, 4 minus 3. Let's visualize it again.
Oh, sorry. I think this is
Just minus. And then, yeah, that's the visualization. 2 minus 5 is minus 3. 3 minus 1 is 2. 1 minus 2 minus 1. 4 minus 3 is 3. That's the answer. Okay. Real quick, let's move into matrix 3 by 3. So the formula to subtract 3 by 3 matrix will be like this. This element minus this element, 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 and this element, this element, this element, this element, blah 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 until this element, until this element. Okay, so the visualization will be like this. This is the formula to find 3 by 3 matrix subtraction. Let's jump into the example. Matrix A and B again. To subtract these two matrices, what I'm gonna do is do this. 2 minus 5, 3 minus 1, 5 minus 4, 1 minus 2, 4 minus 3, 6 minus 7, 7 minus 9, 8 minus 9, 9 minus 8. Okay, and to make it easier, let's see the visualization. It will be like this. 2 minus 5 is minus 3. 3 minus 2 is 2. 3 minus 1 is 2. 5 minus 4 is 1. 1 minus 2 is -1, 4 minus 3 is 1, 6 minus 7 is -1 as well, 7 minus 6 is 1, 8 minus 9 is minus -1, 9 minus x is 1. That's the answer of this question. And now we get into the exciting part, which is scalar multiplication. It's still easy, guys, don't worry. But soon it will get harder. So
So you can give up now.
anyway, scalar multiplication of matrice. So scalar multiplication involves multiplying each element of a matrix by a scalar value. To multiply a matrix by a scalar, it's simply just multiply each element of the matrix by the scalar value. So for properties, scalar multiplication distributes over matrix addition, as you can see at the equation like that. And also associativity holds for scalar multiplication, as you can see the equation. Let's jump into the formula. For example, we have matrix A right here, 2 by 2 matrix. And let's say we have a scalar value of C. The scalar multiplication of A by C denote as like this. So each element of this matrix is multiplied by the scalar, which is C. For example, like this. And then we have C. So this one times this one also times this one times this one times this one. And we got this is the result. CA is like this. This is the formula to find scalar multiplication of a matrix. Let's jump into the example. For example, we have matrix A that have elements of 2, 3, 1, 4, and K is equals to 3. This is the scalar. Okay, this is the scalar. All we need to do is just do the multiplication of each element by the scalar. This one times this one, this one times this one, this one times this one, this one also times this one. Get it? Yeah, it will be like this. 3 times 2 is 6. 3 times 3 is 9. 3 times 1 is 3. 3 times 4 is 12. 9, 6, 3, 12. 9, 6, okay. Correct. Easy, right? Let's get into the next formula. Formula for 3 by 3 matrix. Again, it is pretty much same. All you need to do is just multiply each element of the matrix by the scalar. Okay, this one times this one, this one times this one, this one times this one, this one also times this one, this one 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 times this one, and this one times this one. Yes, this is the formula to find scalar multiplication of a matrix. Let's see the example right here. For example, we have matrix A, 3 by 3 matrix, and we have scalar K equals to 3. Again, all you need to do is just multiply each element of this matrix by 3. 2 times 3, 3 times 3, 9 times 3, 1 times 3, 4 times 3, 3 times 3, 6 times 3, 5 times 3, 4 times 3. Easy? Then we got this. Then 3 times 2 is 6, 3 times 3 is 9, 3 times 9 is 27, 3 times 1 is 3, 3 times 4 is 12, 3 times 3 is 9, 3 times 6 18, 3 times 5 is 15, 3 times 4 is 12. Yes, that's the answer of this scalar multiplication. Yeah, I think that's all for matrix. Thank you so much for watching this video. Psych! We got matrix multiplication. Ha ha ha.
I got you, right? Well, yeah.
Let's continue. Matrix multiplication. So matrix multiplication involves multiplying the elements of rows from the first matrix with the corresponding elements of columns from the second matrix and summing the results. To multiply two matrices A and B, the number of columns in A must be equal to the number of rows in B. The resulting matrix will have the number of rows from the A and the number of columns from B. Let's change the formula. For example, we have 2 by 2 matrix of A and B. To multiply these two matrices, just see what I am doing right here. So first, what I do is multiply this element with this element. And next, multiply this element and this element. Easy, right? And then, again, multiply this element again with this element and this element with this element again. Next, we do to the second row. This element times this element times this element, and then this element times this element times this element. So the visualization will be like this. This is the formula to calculate multiplication between two matrices. Let's jump into the example. Yeah, for example, we have these two matrices right here. Okay, to make it easier, I think I will visualize it like this. This is 2, 3, 1, and 4. And then 5, 1, 2, and 3. So first, I will calculate this one with this one. So 2 times 5 plus this one, 3 times 2. This is for the C11. C12, C12, C12 is 2 again times 1 and 3 times 3 plus 3 times 3. And the next, I see 2 1 times 5 and then 4 times 2. And then C22, 1 times 1, 4 times 3. I will show you this instead, so it will make it clear. It will make it easier for you to understand. And then we just need to calculate it. This one is 10, 9, 2, 9, 5, 8, 1, and 12. Yes, that's the result. This is the result of multiplying these two matrices. It's called matrix AB now. Okay, next, let's find the formula for a 3 by 3 multiplication matrix. Let's assume that we have matrix C right here. Or you also can call it matrix AB because this is the result of multiplication between matrix A and matrix B. So our objective here is to find matrix C. So first, we need to find the elements of matrix C11. To find it is the rows of matrix A and column of matrix B for C11. A11 times B11, A12 times B21, A13 times B31. And we sum all of it. Also same for C12, it's still on the first row, but this time calculate this one for C12, and then for C13 as well, calculate this one. And next, to find C21, we move into the next row of matrix A, and then calculate, and then times this. And for C22, just change into this column, and then C23 just change into this column. And for C31, we move into the third column, and same times this column. For C32, time this column. For C33, time this column. That's the formula to do multiplication between T by 3 matrix. Now let's see the example. To calculate these two matrices, let's do the same with this formula. To find the first row, this one, and this one. Yeah. And next, this one, still the first row. And next, this one, still the first row. And then let's move to the next row. This one, but same column. This one, and then next, this one. Next, we move to the third rows, and same column of B, this one, and then same row of matrix A, then same row of matrix A. So first the first row of C11 until C13 is the first row of matrix A. Okay, and then this one is second row matrix A, and this one third row of matrix A.
Sir, how about matrix multiplication between 4 by 4, 5 by 5, 6 by 6, and so on?
Well, it is not impossible to do the matrix multiplication between 4 by 4, 5 by 5, and so on. But it takes a lot of time and a lot of steps. That's why I recommend you to use matrix multiplication calculator instead. For example, I have this website right here. It's called matrixraces.com. As you can see, this is a matrix multiplication calculator, and yeah, you can set the dimension by yourself. For example, uh, I will do 4 by 4 times 4 by 4, and then we click the set matrix, and then we can input the value of each element. For example, I will just input random number, and because I'm lazy, I will fill the empty cells with 0. Then 5, 2. This one for matrix B. Yeah, let's just put a random number and then fill empty cells with 0. You can also change into decimal mode, and you can also clear the matrix like this. No. And then you can also do a lot of things with this calculator. And then yeah, let's just calculate it. Here we go. Computation time 0.018 second. Oh, that's so fast. And if you want the detailed solution, you can click the show solution. Then you can see a bunch of steps. Oh my god, that a lot of steps. Then you can also recalculate with matrix addition or matrix subtraction. You can also continue this matrix with the next calculation. You can choose between those. So this is matrix multiplication calculator. matrix inverse. So the inverse of square matrix A denoted as
blah 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 blah.
so it means that matrix A will be like this. Matrix A inverse. Matrix inverse is really related into identity matrix. This one is 2 by 2 identity matrix. And so on, we will be faced into 3 by 3 matrix. 1 1 1 0 0 0 0 0 0. That's 3 by 3 identity matrix. For the properties, you can read it by yourself later. Now I will just explain how to matrix inverse. So this is the formula to find the inverse of matrix 2 by 2. So let's assume that we have this matrix right here, matrix A of 7, 2, 17, and 5. First, we just need to insert the elements of each matrix. For example, A is 7, D is 5, B is 7, B is 2, C is 17, and then D is 5, B minus 2, minus B negative 2, and C negative 17, and then 7. And I will show you the visualization like this. It will make you easier. 7 times 5 is 35, and negative 2 times 17 is negative 34. Will be like this, and then this will be 1. That's the result of the inverse of matrix A. So to prove it, if it is correct or not, you just need to do the matrix multiplication between the normal matrix and matrix inverse. It will be like this. So all we need to do is just this one times this one, and then this one again times this one, next this one times this one, and then this one again times this one, like this. This one will be 35, this one will be 35, and minus 34, blah 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 blah. Let's just skip it, and then yeah, that's the result of the equation. This will be 1, 0. This one also 0. This will be 1. And that's an identity matrix, guys. So if the answer of this multiplication is identity matrix, it means that your matrix inverse is correct. And now I have another example right here. This is the matrix B with 8, 6, 5, 4. I just input it. 8, 4, 6, 5. And this one 4 minus 6. C is minus 5 and 8. Visualize it like this. This one is 32 and this one is 30. This will be 1 per 2, I think. Yes, 1 per 2. And then we just need to multiply this each like a scalar multiplication. This one, this one, this one, this one. Then it will be like this. And again, let's prove it if it is correct or not. By multiplying matrix B with matrix B inverse. Again, this one times this one, and then this one again times this one again, this one times this one times this one. Just like that. This one will be 16, blah 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 blah. Let's just keep it. Then this one, okay, this one will be 1, 0, 0, and 1. That's another identity matrix. It means that the inverse is correct. So how about 3 by 3 matrix? Here we have 3 by 3 matrix. So to find the inverse of 3 by 3 matrix, we need to structure it with the 3 by 3 identity matrix. So our objective is to change this one to identity matrix. After that, this area will change into the result of the matrix inverse. Okay, maybe first I want to change this one into 0. So I will do row 1 minus row 3. 1 minus 1 is 0. 2 minus negative 1 is 3. Minus 1
minus 0 is minus 1, and this one 1 minus 1 is still 1, this one 0 still 0, 1 0 minus 1 minus 1. Next, I want to change this one into 0. So to do that, I will need to do this 2 times row 1 plus row 2. So 1 times 2 is 2 plus minus 2 will be 0. 2 times 2 is 4 plus 0 is 4. Minus 1 times 2 is minus 2 plus 1 is minus 1. 2 times 2 plus 0 will be 2. This one will be 0 still. This one will be 0 plus 1, 1, 0 plus 0, and this one will be 0. And next, I want to change this into 0. So what I do is multiply row 2 by 3 minus 4 times row 3. So 0 times 3 is 0, and then yeah, it will be 0. And 4 times 3 is 12, minus 3 times 4 is 12, it will be 0. So that's minus 12. And then this one will be minus 3, this one will be minus 4, and the result will be 1. This one will be 6, minus 4 will be 2. This one will be 3, minus 0 will be still 3. Then 0 minus 4 will be 4. Next, I want to change this one to 0. I need to do row 1 plus row 3. So 1 plus 0 is 1 still. 2 plus 0 is 2. Minus 1 plus 0 is minus 1 plus 1 is 0. 1 plus 2 is 3. 0 plus 3 is 3 as well. 0 plus 4 is 4. And then next, I want to change this one into 0. So I will do row 2 plus row 3. So this one plus this one is 0. This one plus this one is 0 still. This one plus this one is 0. This one plus this one is 4. This one plus this one is 4. This one plus this one is 4. And then I need to change this to 0. So what I need to do is 2 row 1 minus row 2. So this one times 2 minus row 2 will be still 2. 2 times 2 is 4 minus 4 is 0. And 0 times 4 blah blah blah. And then it will be still 0. 3 times 2 6 minus 4 2. 6 minus 4 2 as well. 4 8 minus 4 4. And then next, to make it quick, I will make this one into 1, this into 1 as well. Row 1 times a half, and row 2 times quarter. So it will be 2 times half is 1, and then 2 times this one will be 1 and 1 and 2. 1 and 1 and 2. This one will be 1. This one will be 1 1 1 1 1 1. As you can see, guys, this one has changed into identity matrix, and then this one is the inverse of matrix A. Yes, this one is the inverse of matrix A. And then let's prove it with do multiplication between matrix A and inverse of matrix A. Let's make it quick. This one times this one, and then this one, and then this one. This one times this one, this one, this one. Then this one times this one, and this one. So it will be 1 0 0 0 1 0 0 0 1. Yes, the answer is identity matrix. It means that this matrix inverse is correct. Okay, I think that's all for me. So If you want to challenge yourself, I have a final boss for you. I want you to find the matrix inverse of this matrix. And I will not give you the answer, but you can find it by yourself using multiplication between two matrices. If the answer is identity matrix, it means your matrix inverse is correct. Thank you so much for watching. Hope you guys are doing well and see you later. Пока!